Okay, so welcome back. I said we were going to learn some Python in the next video. I just forgot we had one more question to do. But it's okay, it's a very short question. It's nowhere near as hard as the last question. So let's read the question. So, we've only been working with finite sets. So when I mean finite, I mean you can count how many. It doesn't go to infinity. It's like 1, 2, 3, 4, 5, 6. Like that's a finite number, and you can. It's a bit tricky when it doesn't go all the way off to infinity. Or you can sort of count how many elements in your set. Okay, use your ninja skills to collect intel on the following sets. So you have to go to Google and research this kind of thing. So I say natural numbers, integers, rational numbers, and real numbers. So it's not that bad. You just pull up another tab, you just type in rational numbers, real numbers, or whatever, and you get the answer. I'm not going to write anything. I'm just going to show you the solution here. So here, these are important sets. So the natural numbers, they are the numbers starting at 1, 2, 3, 4, 5, and so on to infinity. They're natural. The integers are like the natural numbers, but you also have all the negative numbers. So from negative infinity, and you come in at negative, like it doesn't matter where you come in, but so all the negative numbers, 5, -5, 4, 3, -6 as well, -7, 0 including, and you go 1, 2, 3, 4, 5, 6. So it's all the natural numbers, and then their negative components, and 0 as well. The rational numbers, this is a non-technical definition, but it's essentially just fractions. So numbers you can represent as fractions. So that could be, for example, let's just go to the board. So that could be, what could it be? It could be use 0.8. That's a rational number because you can represent it with a fraction. So that is actually this fraction here, 8 over 10, or you can simplify that to 5 over 4. So you can write this as a fraction. Numbers you can't write as fractions, unless you're doing something a little bit more advanced or trigonometry or something like pi. That's an irrational number. It's 3 point blah 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 blah. I don't know, 1, 5, 2, 9. I don't know. Calculators can do that. You don't need to remember pi to 6 billion digits. But what I was gonna say is that you can't actually express this as a fraction because it has some other definition. Another one is e. You can't express that as a fraction either. It's like 2 point something 17 maybe. It has a complex definition. It's like a limit definition. But anyway, so you can't write it as a fraction. So that is rational numbers. Now the final set of numbers, the real numbers. The real numbers, also a non-technical definition. I say non-technical because if you do like university math, they actually define these things very properly. But for you, and just let's understand it, it's the complete number line. So you draw the number line. Here's 0, for example, and it's just everything, just all the numbers in the number line, everything, like rationals, irrational numbers, pi, it's everything. Okay, so that was great. We discussed these sets of numbers. We may need them later, maybe not, we'll see. So next up, we're going to discuss Python. We're going to start using Python to help us with our probability endeavors. Okay, so get your Jupyter set up, Jupyter environment set up and stuff, because we're going to start writing some code. So I'll see you guys in the next video.